Artificial intelligence often feels mysterious because we mostly see the results, not the process. A system answers questions, writes text, recognizes images, or predicts outcomes, and it happens quickly. That speed can make AI seem intelligent in a human sense. But in reality, AI works through a combination of data, mathematics, and probability. There is no thinking, awareness, or understanding involved. What exists instead is a system trained to recognize patterns and make predictions based on them. In simple, we can say AI is about learning from examples. Every AI system starts with data, large amounts of it. This data can include text, images, numbers, audio, or records of human behavior. The system does not know what the data means. It only sees it as structured input. For example, when training an AI to recognize faces, the system is shown millions of images along with labels that indicate what is present in each image. Over time, it begins to notice recurring patterns, edges, shapes, relationships between pixels. The same principle applies to language, medical data, financial transactions, or any other domain. Without data, AI cannot learn. The quality and relevance of the data matter more than the complexity of the system itself. The data is processed through a model. A model is a mathematical structure made up of many adjustable parameters. These parameters are tuned during training. Training means the model is shown examples and asked to make predictions. When it makes a mistake, the system adjusts its parameters slightly to reduce future errors. This process repeats millions or billions of times. Over time, the model becomes better at predicting likely outcomes. AI does not store knowledge the way humans do. It does not retrieve facts from memory. It calculates probabilities based on patterns it has learned. When an AI generates text, it is not recalling a sentence it has seen before. It is predicting the next word based on the words that came before it. Every response produced by AI is a probability-based decision. Given an input, the model calculates which output is most likely based on its training. This is why AI can sound confident even when it is wrong. The system is not verifying truth. It is choosing what appears statistically plausible. This also explains why the same question can produce different answers. Small changes in phrasing can shift probabilities and lead to different outputs. AI is not searching for the correct answer. It is selecting the most likely one. Most of the learning happens before an AI system is released. Training requires enormous computing power and time. Models are trained on specialized hardware using vast data sets. Once training is complete, the model is deployed and used by people. When you interact with AI, you are not teaching it from scratch. You are using a system that has already learned patterns from its training data. Some systems adapt slightly over time, but the core learning phase happens beforehand. This is why updates and new versions matter so much. Improvements usually come from retraining with better data or better model designs. AI can handle context within defined limits, but it does not understand meaning, intention, or consequence. It does not know why something matters. It does not understand emotions. It does not grasp ethics or values. It simply models relationships between inputs and outputs. When AI appears to reason, it is actually following learned patterns that resemble reasoning. This can be useful, but it is not the same as human judgment. This limitation is especially important in areas like healthcare, law, or finance, where context and responsibility matter. AI performs best when it operates within clear boundaries. When tasks are well defined and data is consistent, AI can be extremely effective. When problems are ambiguous, emotional, or ethically complex, performance drops. This is why AI excels at tasks like pattern recognition, optimization, and prediction, but struggles with open-ended decision-making that requires judgment. The more freedom an AI has, the more careful humans must be in interpreting its output. Despite how it may appear, AI does not act on its own. Humans decide what data it sees, what goals it is optimized for, where it is deployed, how its outputs are used.